March 2008. The hand, foot and mouth disease plagues Asia once again. April 2008. A global food crisis erupts. Troubled world ahead. Enter the new farmers. Skillful with soil, dexterous with livestock, they are professionals outdoors and inside their labs. How is Taiwan's agricultural biotechnology solving some of the world's most pressing problems? We find out. Agriculture, the backbone of civilization. But here in Taiwan, the next wave in farming will take place not just in the fields, but also in its labs. Cells, viruses, and bacteria will tackle mankind's perennial problems. And one problem Taiwan is addressing is something very close to home. 2008, now known as the year of the global food crisis. The price of rice doubled, wheat prices increased by 200%. Prices for food were high and in short supply. Today, there are 6 billion of us. In 2050, there will be 3 more billion. The World Bank predicts we will demand twice as much food. Farming land will not get any bigger, but our populations will. How can we grow enough to feed burgeoning appetites? The answer is in the hand of soil scientist Dr. Yang Chu Chong. In this soil is a bacteria called Bacillus pumilus. It can make crops healthier, and without increasing land space, harvests can get bigger. Exactly what is needed at a time when food seems to be getting scarce. B. pumilus works this way. Plants require a nutrient called phosphorus. It tries to absorb it, but it cannot. B. pumilus fixes the problem. The acids it produces dissolve the stubborn chunks. Now that it's nice and fine, the plant absorbs with ease. Unfortunately, in most soils around the world, a high-performing strain of B. pumilus is rare. That's why 90% of phosphorus in soil remains stuck and unused. Over the years, Dr. Young has discovered a strain of the Bacillus pumilus bacteria that proves to be more effective than the rest. This star performer is able to help plants grow stronger, taller, and with more yield. His goal is to create a fertilizer made up of this most efficient strain of the Bacillus pumilus.
我们分离这个菌种呢，它的名字叫做 Bacillus pumilus， 就它的特殊性就是属于这个杆菌生长速度很快的一种，所以这个在应用上就很有价值，因为未来可以在土壤里面让很快的这个磷肥呢分解出来，变成植物可以利用的这个磷。除了溶磷的这个功能之外，它还有促进植物的生长，把根系长得更好。那根系长得好呢，就是植物就吸收更多钡的元素的功能，所以这个也是促进植物生长的一个重要的一个特殊性的地方。
Dr. Young's strain of the B. pumilus has since been transferred to industry. It is now packaged as a biofertilizer by one of Southeast Asia's largest plants. The Advanced Green Biotechnology Inc. B. pumilus will enter the markets and be christened FERT-P. If fertilizers made out of bacteria sound radical to you, how do you think a traditional rice farmer like Li Rongheng feels? Well, Li's game for an experiment this harvest season. He has 2 rice paddy fields. Field A has been nourished by FERT-P. Field B by conventional chemical fertilizer. which will yield the better harvest. The result shows that Field A, nourished by Fert P, has more tillers, a good plant length, and more tassels per unit area than Field B. It clearly reveals Field A's ability to grow healthy, abundant grain, all thanks to biofertilizers.
用恁这款的类大约啊，我甲算下哦，伊差不多3分加1分该有啦，差不多大约啊，差不多安啦。
It is harvest time, and by the looks of Lee's returns, it will be a good year. Besides prosperous harvests, biofertilizers like Fert P also reap excellent health benefits. Chemical fertilizers often leave traces of harmful elements on crop produce, and unfortunately, they often end up on your dinner plate. Healthy soil makes healthy people is AGBT founder Liu Fengzhi's personal calling. A liver cancer survivor from 1995, Mr. Liu was advised by good friend Dr. Young to switch to fresh produce grown by biofertilizers.
这我是在2002年的4月创立的。这个因为那个时候我因为生病了之后，医生说没有问题了，你身体已经好了，我才知道说这个微生物的这些肥料以及微生物的农药。 是对我们人体是非常重要的。
The mantle has since been passed on to his son, Ken Liu, who shares his father's belief in the health benefits of biofertilizers.
10年前，台湾罹患癌症的人口比例，跟目前来讲，现在可能是6个人就有1个人得到癌症。我有这个机会可以做这个产业，我想是对台湾人，或者对亚洲人，对全球都是一个有正面帮助的一个产业。 那我也希望这个产业可以继续持续的发展，而我也相信这个产业是明日之星，是不会改变的。
What started as caring advice between two old friends sparked the beginning of a rapidly expanding biofertilizer plant. A reminder that perhaps sometimes all you need is that one seed of passion to nurture your dreams and touch others. Coming up, is meat getting a little too expensive lately? Find out how a savvy lab technique called rapid array can keep animals healthy and in turn save you money. The Americans have their burgers, the Chinese their meat buns, the Japanese their pork katsus, and here on the island of Formosa, luscious Taiwanese sausages. While veggies keep us healthy, here in Asia, meat is what makes the meal hearty. And by the looks of our growing middle class, we will only love our meat more. The United Nations reports that every second there's an Asian being added to the world's workforce. Asians with spending power. By 2009, families earning $3,000 or more will have doubled from 5 years ago. They'll be earning salaries good enough for vacations and definitely some fine dining, meat included. The result? Asia's growing rich will continue to drain resources, which was a key reason why meat and food prices rose sharply in 2008. Among the various types of meat, beef saw substantial increases. And while our love for meat will stay, animal disease need not. Cattle tuberculosis has long been the culprit for rising costs in the cattle industry. It infects more than 50 million cattle worldwide and is every farmer's nightmare. Each year, it causes an estimated loss of $3 billion worldwide, mainly because it spreads so easily, whether sharing a drink or just hanging out at the barn. Cattle tuberculosis spreads like a common cold. Worse still, the cattle may only start looking visibly sick years after the infection. By then, the entire herd would have caught the disease. But what if you could detect it earlier? In comes the rapid array. Sounds like a cool gadget, but it's really a setup of some very sophisticated lab equipment, all with one aim: to find out if 36-month-old Jenny has cattle tuberculosis. Rapid Array is a test kit developed by Taiwanese biotech company Asia Gene Corporation. It's one of the world's fastest, most reliable and sensitive ways of diagnosing animal diseases, such as the classical swine fever that strikes pigs, and the Newcastle disease and avian reovirus, which affects poultry. Dr. Liu Hongreng from the National Pingtung University of Science and Technology is part of the team who engineered the Rapid Array.
tuberculosis 它这个如果感染到这个牛只，必须要被淘汰，所以对这个 farmer 那是影响当然很大，损失很严重那第二个，如果这个感染以后没有被检测出来，它生产的牛奶被人们喝了以后，那我们这个病原菌就可能会传给大众造成这个公共卫生的一个很严重的问题。
Jenny's doing fine lately. If she has cattle tuberculosis, she's probably only at the early stage. But it is still contagious. Dr. Liu Hongren will put Jenny to the test today. Rapid Array's sensitivity lies in the first stage of its entire workflow, the nested PCR stage. This is a chemical reaction devised by Dr. Liu's team to increase the quantity of DNA in Jenny's blood sample. Expanding the DNA also increases the probability of detecting the bacteria. The process can be easily explained using a simple analogy. Imagine a stack of paper clips. In this stack, there are several kinds of paper clips, each representing a different kind of DNA in Jenny's blood sample. What we're trying to look for are the metal ones, which represent the M. bovis DNA, the agent that causes cattle tuberculosis. What happens in the nested PCR stage is that it increases the number of metal paper clips within the bunch. So even if Jenny is in the early stages of infection, where traces of the bacteria are extremely low, the process will expand the amount of bacteria DNA, allowing for easier detection. However, there are many kinds of DNA in the sample right now. Normal DNA and bacteria DNA are mixed together. If Jenny does have the M. bovis DNA, it will be jumbled up with the other DNA. What Dr. Liu has to do now is sort them out. This marks the second stage of Rapid Array. On these magnetic beads, Dr. Liu adds a specimen of the M. bovis. The theory is that like attracts like. These M. bovis on the magnetic beads will seek out their fellow bacteria in Jenny's sample. Returning to our example of paper clips. Right now, in this stack, there are many kinds of paper clips, all mixed up. To sort the metal ones from the rest, we introduce a magnet. Just like the magnetic beads in the second stage of the Rapid Array, the metal paper clips will be attracted to the magnet, thus separating themselves from the rest. Now we're ready for the results. A reading of 100,000 units and above means that Jenny is positive for cattle tuberculosis. Fortunately, her reading is very low. Dr. Liu gives her the clean bill of health. Tenderly, these farmers have nurtured their flocks from just a few pairs to the healthy broods and herds today. Proud farmers they are. They also share a similar sense of dread.
口蹄疫在10几年前，因为那时候从大陆进口小猪进来，所以台湾被感染到。那一年，真的台湾真的损失惨重。我在那一年，一天就损失4万块的台币，整整1年。
Early detection and speedy treatment has long been the key to business viability, but it's easier said than done. A pig may only show classical swine fever symptoms 3 weeks after catching it. Liabilities incurred? treatment expenses, miscarriages, and delayed arrivals at market.
我们可以利用这个技术，快速的侦测或是诊断特定的疾病，因为它的敏感度非常高，特异性非常高，对农民当然是有很大的帮助。
It took Jenny less than 5 hours to be given the clear. Current diagnosis methods, however, can stretch for days. The time saved using rapid array means sick animals can be treated faster or separated from the rest of the herd, and epidemics can be prevented. After the break, painful blisters, tedious hand soaping, and constant temperature checks. Now scientists in Taiwan aspire to quell the hand, foot and mouth disease misery using something quite unusual: chicken egg yolks. There's a time of the year when kids get jittery. It's not exam fever, but the heat is on. The dreaded hand, foot and mouth disease, or HFMD, is traditionally the low point of humid July. The warmer months of the year, a breeding utopia for EV71, one of the viruses that cause HFMD and possibly the deadliest. In Taiwan, a major outbreak of the EV71 virus in 1998 infected over 400 children, leaving 78 dead. Thankfully, most cases aren't fatal, but neither are they pleasant. Fever, sores, and a lack of appetite. The illness is painful, whichever way you see it. The race is on for the world's first vaccine for EV71. But the truth is, a good vaccine will take years. A team of scientists in Taiwan think that action must be taken now. Dr. J.J. Tai Lu, a leading livestock researcher in Taiwan, believes that the solution we're looking for lies inside this. Yes, an egg. EV71 fighting antibodies. Milligrams of it are slithering on this sunny side up. But how did it even get there? The story begins here at the chicken coop house. Dr. JJ causes quite a stir. She looks for little Rachel, a 12-month-old hen, who will help us out today. Mother hens, famous for their protective love. Dr. JJ Tai Lu will show you why with this syringe. Warning, the deadly EV71 is looming inside. After Dr. JJ's injection, little Rachel gets a mild attack of EV71. However, she doesn't fall ill, but she did gain immunity. Afraid that her chicks will fall ill too, her biological response is to pass the same immunity to her eggs.
对一个母鸡来讲，它在这个整个免疫，如果说它接触到抗原的时候，它有一个自然的一个反应，就是它会把它抗体储存在它的蛋黄里面，因为就像一个妈妈她要保护她的胎儿一样，她有一段时间她会透过她的血液循环把抗体留给她的胎儿。那这个母鸡也一样，它是存在蛋黄里面，然后让那个蛋黄当小鸡在孵化的时候有这个抗体的来源。
It's been a week. Little Rachel's doing well, and Dr. JJ has collected her eggs for some tests. The eggs are broken, the yolk separated, and the thick yellow liquid is pooled in this container and stored in the freezer. Dr. JJ and her team will now attempt to extract that immunity-causing substance from the egg yolk. What she's interested in are the antibodies that can prevent EV71 infections. Earlier, the egg yolk was diluted. It's now placed on this vibrating centrifugation, which drains out the fatty solids inside. What remains is a nice clear liquid. But the job's not done yet. In the last stage, the mixture is further purified in another round of centrifugation. Each little drop of liquid here is a concentrated drop of antibody goodness destined for fighting the EV71 virus. While the world is competing to find the first EV71 vaccine, Dr. JJ and her team decided against it. Instead, this is their vision. The antibodies that they have discovered will be refined to a powder and manufactured as immunity boosters. It can be in the form of a vitamin, or added to milk powder, or even as a supplement added to Junior's apple juice.
有一些研究显示说，那个蛋黄其实在蛋黄的形式反而对这个抗体的效果反而更好，因为它可以耐过胃酸的一些消化。所以呢，我们是说，如果我们用蛋黄的形式直接，比如说做成胶囊啦，或者是做成 candy 啦，或是做成什么 drink 很好喝的 drink， 让小朋友要去上课幼稚园之前能够先喝一下，然后让他今天有一个保护作用，这是我们想要开发的一个目的。
The team's work on EV71 is now in the process of patent approval in the US and Taiwan, and is on its way to reaching industry. When it does, it will certainly bring cheer, especially to a few particular months of the year. No longer is agriculture the backward cousin of our modern economy. The marriage of technology and agriculture is real and inseparable. It will contain the answer to age-old problems. From manipulating soil bacteria to relieve food shortages, to ingenious techniques done with egg yolks and lab technologies to prevent diseases. Agricultural biotechnology will transform the way we eat, work, and live.